Hello everyone. Let's see the case study on IEEE 802.11a wireless local area network standard. In this video, we see the properties of the system design and discuss some of design choices. So here the table illustrates 802.OFDM system physical parameters. Here in 802.11a, the 64 subcarriers are generated. 64 subcarriers are generated. N is equal to 64 subcarriers generated, although the only 48 subcarriers are used, okay, for data transmission. The outer 12 subcarriers are zeroed in order to reduce the adjacent channel interference, okay, adjacent channel interference. Here the other four are only used as a pilot subcarriers. So data subcarriers 48 samples, and here 4 are used as a pilot subcarriers for channel estimation. Okay, coming to the cyclic prefix length. The cyclic prefix length, think about 16 samples. It has 16 samples. The total number of samples, associated with OFDM symbol. So OFDM symbol structure, it consists of the two IFFT data, actual data subcarrier and the cyclic prefix. Here the total number of sample associated with each OFDM symbol, including both the data samples and the cyclic prefix. So 16 plus 48. Sorry, this 48 plus 4. This actually, see, the number of subcarriers is 64, right? So this is 64. So 48 plus 4 and plus 60, 12. Okay, so 64. 80 samples. So the total number of samples associated with each OFDM symbol is 80 samples. So as you can see the right side, this OFDM symbol in frequency domain, as with the subcarriers, and the OFDM symbol in frequency domain. So the bandwidth of the signal is 20 megahertz, and here 48 data subcarriers, 4 pilot subcarriers are used. Okay. Here the error correction code, convolutional code used. Error correction code is nothing but convolutional code with one of three possible rates. One of the three possible code rates used. Okay, the modulation types that can be used on the subchannel or BPSK, QPSK, or 16 array QAM or 64 array QAM. The total system bandwidth of the signal is 300 megahertz divided into 20 megahertz channel that can be assigned to different users. So the 300 megahertz, the total bandwidth is divided into 20 megahertz channels that can be assigned to different users. So since the channel bandwidth is 20 megahertz, nothing but B is equal to 20 megahertz. Since there are 64 subcarriers evenly spaced over the bandwidth, the subcarrier bandwidth B, so it is denoted by Bn, okay, Bn. So the subcarrier bandwidth 20 megahertz divided by, so the channel bandwidth divided by the number of subcarriers, so 64. So we get the subcarrier bandwidth is 312.5 megahertz. As you can see here, the subcarrier spacing or subcarrier bandwidth 312.5 kilohertz. Okay, let us find the maximum delay spread for which ISI is removed. So find the maximum delay spread. Maximum delay spread, that is nothing but that is denoted by TM, for which ISI is removed. For which ISI is removed is uh, since the cyclic prefix length 16, and the bandwidth is nothing but 1 by ts nothing but 20 megahertz. So therefore the TM, the delay spread, less than the cyclic prefix length, mu into ts. So 16 into 1 by 20 megahertz, that is 10 power 6. So what is TM? TM is nothing but TM is nothing but 16 into 0.05 into 10 power minus 6, that is TM less than 0.08 microsecond. So which corresponds to the delay spread in indoor environment. Okay, so including both OFDM symbol and the cyclic prefix, there are 80 samples. 80 samples. Those 80 samples total, right? So including cyclic prefix and the IFFT data, so 64. Okay, so the total 80 samples per OFDM symbol time. So the symbol time per subchannel. So the symbol time, that is denoted by TN. The symbol time per subchannel, symbol time per subchannel is nothing but Tn equal to n times Ts. N 80, the total subcarrier samples 80 divided by 20 into 10 power 6. Okay, 6. Then what is Tn? Tn is nothing but 4 into 10 power minus 6 seconds. It's nothing but Tn, the symbol time, 4 microseconds. Okay. So the symbol time per subchannel is calculated. That is 4 microsecond. So then what is the IFFT symbol time? See, you know the structure. The OFDM symbol consists of the IFFT data and the cyclic prefix. Here the symbol time, here the cyclic prefix symbol time is nothing but 0.8 microsecond, and now the Tn is found, that is the total time, total symbol time, that is 4 microsecond. Then rest of part, it's nothing but the time, I50 data time, interval time is nothing but interval time, that is nothing but T IF of T is equal to Tn minus mu into Ts, that is nothing but Tn. What is Tn? 4, the symbol time 4 minus this 0.8 microsecond. So this what is this T IF of T data symbol time interval is nothing but 3.2 microseconds. Okay. Okay, now let's see the data rate per subchannel. The data rate per subchannel is okay, let's see the data rate. So here in IEEE 2.2 0.11a, we are going to see the the minimum and the maximum data rate. Okay, so the data rate per sub channel, so the number of bits required to represent symbol log base to m divided by the symbol time. Okay, and therefore the minimum data rate, that is denoted by r min for the system corresponding to the BPSK, that is 1 bit per symbol, and r equal to 1 by 2, and only 48 subcarriers actually carrying the data. So therefore the r min, minimum data rate r min 48 subcarriers into the code rate 1 by 2, and BPSK modulation, so only 1 bit per symbol into 1 carrier symbol divided by the the symbol time, that is symbol time nothing but 4 into 10 power minus 6. So r min 6 megabits per second. So the maximum data rate, then what is the maximum data rate that can be transmitted? The maximum data rate r max that can be transmitted, since r is equal to 3 by 4 and 64 array QAM modulation. So r max nothing but 48 3 by 4 with the code rate 3 by 4 and 64 array QAM modulation. So nothing but m equal to 2 power 6. So 6 bits are required to represent one symbol. Therefore the 6 coded bit per subcarrier symbol divided by the symbol time, that is nothing but 4 into 10 power minus 6. Okay, so therefore the maximum data rate that can be achieved since the 64 array QAM coded OFDM system 54 megabits per second. Therefore the maximum data rate r max equal to 54 megabits per second. Okay, so now we learned the case study on IEEE 802.11a wireless standard, the data rate, the symbol time period, and the samples. Thank you.